This is a right angle trigonometry review video, and we're just going to go through just the basics of trigonometry just for revision purposes. Recall that trigonometry relates ratios of sides of a right angle triangle to either of the two angles in a right angle triangle, obviously other than the right angle. So if you take this first triangle here, I've marked an angle inside the triangle as theta, and obviously the size of theta depends on how long the opposite side is, for example, compared to say the adjacent side. So as you squash up one of the sides, the angle will change in value, for example. So if we were to make the adjacent side shorter, but keeping the opposite side fixed, then theta will get a bit will get bigger. Okay, so basic rule is this. Okay, sine. Okay, so we pronounce it sine, not sin. Okay, so some people just look at it and read it as as it's written phonetically. It's actually sine, S-I-N-E. So sine theta is equal to opposite over hypotenuse. Okay, now why is it called the opposite side? It's called the opposite side because this is the side that's in fact opposite the theta. Okay, that's why it's called opposite. So we need to, when we're labeling a triangle, we need to consider where the theta is and then label the triangle accordingly. Okay. The hypotenuse, of course, is the longest side, and that's always opposite the 90 degrees. So wherever the 90 degrees, the hypotenuse is obviously opposite that. Then we have cos, okay, which is cosine, but we can say cos theta is equal to adjacent over hypotenuse. Okay. And lastly, tan, okay, which is short for tangent. Okay. The origin of these words, I do have another video where I talk about where all this sort of comes from. Not that it's necessary, but it's nice to sort of appreciate where these trigonometric ratios come from. But tan theta is in fact given, it's actually sine theta over cos theta. Okay. So if ever the tan button on your calculator stops working, there is a way to achieve or to calculate the tan ratio, which is just sine theta over cos theta, and that's in fact the ratio opposite over adjacent. Okay. Now, if the angle changes, so instead of the angle being down the bottom, the angle is now up the top. So I've indicated that with an angle alpha there. Do the ratios change? Well, the labeling changes. The ratios stay the same in the sense relative to theta, the ratios are still identical. So sine of alpha, okay, and you could use anything you like there to indicate the angle. I'll just use the two Greek letters there, alpha and theta. So sine of alpha again is opposite over hypotenuse. Okay, but this time the opposite side again has to be opposite, or the furthest away from alpha. Okay, hypotenuse again, as per usual, hypotenuse is always opposite the 90-degree angle. Okay, cos of alpha is equal to, again, adjacent over hypotenuse. Okay, and tan of alpha is equal to opposite over adjacent. Okay, now all this can be quite easily remembered with this mnemonic. SOHCAHTOA, you've probably seen this in class. Okay, SOH, sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. In the next video, I'm just going to look at some basic examples around these.